Okay, let's put down the automatic stuff. What's one automatic thing we can put on here? Range, that will be everything, and good. Amplitude will be none. Perfect. All right, the only major difference for how you go through these than the other ones is that the period is just pi over whatever's in front of the x instead of 2 pi over whatever's in front of the x. Everything else is really the exact same. So it'll be pi over a half, which means you're multiplying by 2, it'll be 2 pi. All right, phase shift. Do you see anything added or subtracted in here? No, so that's great. It's nothing. You can say 0 or you could say none. And then vertical translation is also 0 or none. Look, 3 out of the 6 answers were none. Great. Let's get the f of x values first. I think those are easier. Remember, we're only going to go halfway around the circle. We're doing tangent, so it's y over x, and then we'll multiply it by 2. If you want to block off the trig function, you can do that. We're going to go to the circle, whatever we get, we'll double it. So the first one, 0 over 1 would just be 0 times 2, still be 0. The next one would be 1. Are you guys following me? We're only going to go halfway around. We're making this messed up. That would be 1 times 2, 2. Now we're at the top of the circle, 1 over 0, undefined, good. Now we're in quadrant 2, so it's -1 times 2, -2, and then back where you started. What goes in the first box? 0, the phase shift, good. And I'm going to put 0 pi. You can just put 0. I usually like to put 0 pi because then we're going to add the period, which is 2 pi. And then we have to break that down to what's in between. So what's halfway in between those? 1 pi, like a whole pi, and then halves. So pi over 2, 3 pi over 2. Actually, those just turned out to like the unit circle points, which is nice. So when you go to plot those, I want to count by halves. Just skip the first one and call the next one pi, and then you know that they're halves. And then we're just going to plot those. I want you to show 2 full cycles, so 2 wiggly thingies. All right. So 0, 0, start at the origin. And then pi over 2, 2. And then an asymptote. And then -2, 0. So the pattern goes -2, 0 to asymptote, -2, 0 to asymptote. And you can draw more if you want, but that's all I need. 2 of them is good enough. And then just don't forget to go back and do the domain. It's everything except where the asymptotes are. So where's the first one? Pi, good. And then it's plus how often they happen, which you can, there's a lot of ways you can think through that. You can kind of look at the table, you can look at the graph, or it's going to be the period of the function. So plus 2 pi n. The n takes care of the fact that it's infinite. All right, let's look at the next one. Range is going to be everything, and then amplitude is going to be none. Now we're going to have to factor the equation, okay? Also see that -2 out front? A lot of times that bothers people if you want to write that at the end instead of the beginning. It doesn't make a difference where it's written. It's just a lot of people tend to like it to be written at the end better. So we'll kind of rearrange this. We're going to have 1/2 tangent, and then kind of like leave yourself a space. We're going to factor that. And then if you want to put the -2 at the end, you can. Again, for some reason, it just throws everyone off when it's written out front. I get it. It's not like as familiar. But we're going to have to factor out that 4. I'm not going to make you factor every single one of them, but I'm going to throw you a couple, okay? Because I think you can factor. Actually, I know you can. If you factor out 4, what would be left? Good, pi over 4. You're dividing, perfect. You're dividing by 4, pi over 4, that's it. You have to do that to see what the phase shift is. That's the point. So here, let's answer phase shift. Did we go left pi over 4 or right pi over 4? Right, so you can just say pi over 4 or right pi over 4. And then what's your vertical translation? Well, down 2. So you would say -2 or down 2. All right, we're gonna have to wait on the domain. The period, this is again, the one big difference. Instead of 2 pi, you're just gonna use 1 pi. It's easy to do, but it's also easy to forget. So like that comes from practice, right? And it'll be pi over whatever's in front of the x, which is 4. This one got very, very compressed. Instead of pi, it's 1/4 of pi. It got very squished together. So just as it heads up, the fractions are gonna get really small here. All right, so when we go to fill in the chart, let's do the f of x values first. We're doing y over x for tangent. And then we would multiply it by 1/2 and subtract 2. So again, if you want to block off the trig function, we're going to get that from the unit circle, multiply it by 1/2, subtract 2. All right, what's the first one? Y over x. 0 times 1/2, 0 minus 2, -2. Then this one, 1 times 1/2 would be 1/2 minus 2. 1/2 minus 2, -1 and 1/2 or -3/2. I'm okay with you using the decimal for the y value. All right, now we're up at the top, 1 over 0, undefined. Then we're over here, that's -1 times 1/2, -1/2 minus 2, -2 and 1/2. And then the last one always puts you back where you started, which is -2. So when we go to graph this, the pattern is going to be -2 and 1/2, -2, -1 and 1/2 asymptote, -2 and 1/2, -2, -1 and 1/2 asymptote. That's like the pattern that it's going to be. All right, the phase shift is going to go right here, which is pi over 4. And then we're going to add the period, which weirdly they're the same thing. It's also pi over 4. So pi over 4 plus pi over 4 would be pi over 2. 1/4 plus 1/4 would be 1/2. And this is what I was talking about. It gets compressed so much. We would have to break down the fourths to get to the middle. Fourths break down into eighths, but then we would have to break down the eighths to get what's halfway in between that. So this is going to have to go to 16th. I would not make every problem like this, but I might throw you one, okay? Let's write these as 16ths. 1/4 would be 4/16, and then 1/2 would be 8/16, and then you can just count by 16. So it's really not that bad. Like that's 4/16. This would be 5/16. The next one would be 6/16, which would reduce. That would be 3/8. But honestly, if you were at 6/16, fine, whatever. And then the next one would be 7/16. So it was 4, 5, 6, 7, 8. Like you're just counting in 16th. It's just we had to break it down really small. You guys all seemed like you handled that. Now, how do I make sure each of these tick marks counts as a 16th? Go to the 16th one and call it pi. I'm not sure if I have 16 of them on there though. Hold on. Oh, there is? 16. Okay, perfect. Call the 16th one pi. Now we know that they're 16ths. That's good enough. I don't want to say I don't care, but I kind of don't. Like just go to the 16th one, call it pi. We're done here. Okay. So 4/16, we're at -2. So that's your fourth tick mark. We're going to call that -2 right there. And then the fifth one is -1 and 1/2. And then an asymptote. And then -2 and 1/2, -2, -1 and 1/2, and another asymptote. Again, that was hard with the fractions. If you were like, that was hard, you're right, it was. And I wouldn't make every single problem that hard. It'd be like one of, you know, a test is going to be a collection of easy, medium, and hard problems. Okay? So the domain, everything except where the asymptotes are. So you have to take the first one. Now, the first one landed on the second tick mark, and our tick marks are in 16ths. So that would be 2/16. So 1/8. So the first one is at pi over 8, plus however often they happen, which is going to be the period. So pi over 4n. I'm going to just keep going so we can finish, okay? You guys seem like you're handling this well. This one needs factored. Do you see that 2 in front of the x? We're going to have to factor that out. So let's rewrite the equation. It'll be cotangent, leave yourself a little blank, and then +1. Oh, yeah, I'm sorry. The first one was at pi over 8. And then they happen every pi over 4. It's always going to be whatever the period is. So you kind of just copy that over. So this one we do need to factor, but it's actually not going to be too bad because you're just going to take out a 2, and both of those terms have a 2 in them. So if you take out a 2, what's going to be left? X minus pi. That one wasn't so bad. All right, what's something we can fill in just right away? Range, everything. And then the amplitude, none. Good, vertical translation is up 1. You can just say 1 or up 1. Phase shift, that's why we factored it. You have to look at the factored version. What's our phase shift? Pi, or you can say right pi. And then the period, that's the one thing that's different from the other ones. Instead of 2 pi over whatever, it's just pi over what number for this one? 2. So pi over 2. So instead of pi, it's pi over 2. Again, this one got squished. So I think the fractions might get a little sliced up. I don't think it goes all the way to 16th this time. I can't remember. Anyway, because it got compressed, we're going to have to slice the fractions kind of smaller. Let's get the f of x values first. This one's cotangent, so it's going to be x over y, and then we'll add 1. So the first one, x over y, that's 1 over 0, undefined. What's the next one? 1 plus 1, 2. Like then I get to a point where I'm explaining to a whole room full of like young adults that 1 plus 1 is 2. All right, and then up here it'll be 0 plus 1. So 1. Over here it's -1 plus 1, 0, and then back where you started. So it's going to go 2, 1, 0 asymptote, 2, 1, 0 asymptote. Remember, this one decreases instead of increases. So you're going to start with the phase shift, which we said was pi. And then add the period, which is pi over 2. So pi plus pi over 2. Okay, that would be 1.5 pi, but you can't write 1.5 pi. Perfect, 3 pi over 2. Now you would have to break the halves down into fourths to get the middle, but then you'd have to break the fourths down again to get what's halfway in between that. So this is going to have to break down into what? Eighths, good. So 1 whole pi, how many eighths would that be? That'd be 8 eighths. And then 3 halves would be 12 eighths. And so I think then you can just count by eighths. So we have 8 eighths. The next one would be 9 eighths. And then 10 eighths. You can write 10 eighths. At that point, I don't care. I'm like so happy you got the answer. But that would reduce to 5 fourths if you want to be real particular. And then 11 eighths. So once you get it broken down into the eighths, you just count by eighths. 8, 9, 10, 11, 12. I realize it does look scary though. Like that's intimidating, and then it, like people get flustered. So if you want these to be eighths, go to the eighth one and call it pi. And then you're just taking that information and putting it on the graph. So pi is an asymptote. And then it's going to go 2, 1, 0, and another asymptote. And again, I just want you to continue it. Oh, you know what? Actually, you're going to have to continue this one a third cycle, because to do the domain, you have to find where the first asymptote is. So you have to kind of get all the way back to the beginning. So actually, you are going to have to do a third one for those. But I don't think this graph was too bad. The numbers weren't that weird. All right, so domain, everything except where the asymptotes are. So where are we starting? Where's the first one? First one's 0. That's why we had to keep going and get all the way back to the beginning. But thankfully it's 0. So the first one's at 0 pi plus how often they happen, which is going to be the period. So pi over 2 n. Remember how scary that seemed last time, and now it's not so bad? It's just practice stuff. Get some attention. With me. Okay. All right, one more. We don't need to factor this one, which is good. Let's fill in the automatic stuff. Your range will be everything. Amplitude, none. All right, what else can we fill in? What do you like look at and you're like, okay, I know that. Vertical translation, 3, or you can say up 3. Phase shift, did we go left pi or right pi? Left, so it's not pi, it is negative pi, or you can say left pi. And then the period is pi over whatever's in front of the x. Now there's nothing written there, so it is 1, and so it means that this did not get stretched or shrunk horizontally, like it just stayed pi. All right, cool. This is cotangent. If you want to block off the trig function, that's the part that comes from the unit circle. We're going to make it negative, or if it's negative, we'll make it positive. We're going to negate it and then add 3. All right, what's the first one? We're doing x over y. Undefined. What's the next one? 1, good, but we're going to make it negative 1, good, plus 3, 2. What's the next one? 0, which you can't make negative, so 0 plus 3 is 3. The next one is negative 1. When you negative 1, it'll just be 1 plus 3. Did anyone look at this though and go, oh, it's 2, 3, the next one's going to be 4? Like, yeah, and then undefined. So it's going to go 2, 3, 4 asymptote, 2, 3, 4 asymptote. Oh, I was ready to graph it. I guess I better get the x values. All right, what goes right here? Yeah, phase shift, so negative pi. And then you add the period, which is pi. So negative pi plus pi, 0. So that's kind of nice. Halfway in between the negative pi over 2. And then you have to break the halves down into fourths. So this will be negative 1/4 and negative 3/4. I know the fractions are hard. Fractions are tough, but I feel like, does anyone feel like they're getting better with fractions? If nothing else, getting used to the fractions. All right, so if I want each of these to be a 4th, I'm going to go to the 4th one and call it negative pi. You can go to the 4th one this way and call it positive pi. That's good enough. Now I know that they're all 4ths. And then you just take that information and put it on the grid. So negative pi is an asymptote. And then it's going to go 2, 3, 4, and another asymptote. And you should hopefully be thinking, hey, wait a second, cotangent's supposed to be decreasing. Why is this increasing? Perfect, because there's a negative. You guys are brilliant. And then the domain, it's going to be everything except, where are we going to start? 0. Isn't it nice when it's 0? Bless you. Nothing pi plus however often they happen. So how often are they occurring? Every pi n. Whenever it's tangent and cotangent, it's just adding the period. If you noticed from last time, I usually just tell you to look at the graph, but for secant and cosecant, it's half the period because you have a smiley face and a frowny face. So if you want to remember it that way, like for these, it's just the period. For secant and cosecant, it's half the